Hello guys, let's see continuity of a composite function. So first of all, you should be aware with that we are talking about composite function means if we have two function f of x and g of x, so we can make one composite function as fog of x, basically nothing but f of g of x. So basically this is what my composite function is, and now we have here f of x. Now what will happen is basically what is the condition in continuity of composite function. They said clearly that my composite function will be discontinuous at all the values of x where my g of x is discontinuous, okay, and also at the value of g of x, okay. Now so let's take the example f of x is given as 1 by 1 minus x. In this f of x is 1 by it, and it is already mentioned that it is discontinuous at x. You know that point of discontinuity we can find out by keeping the denominator equal to 0. So point of discontinuity is x is equal to 1. Now if I'm going to find out f of x, what will happen here is in place of x I'm going to replace with the 1 minus x, because we are finding f of x. So what we got is x minus 1 divided by x. So we know already this is discontinuous at x is equal to 1, but it is also discontinuous at x is equal to 0 by the problem itself we know. Now again we are going to check f of x. It means again we are substituting this x value in this, f of x value in this, in your f of x value in place of x, basically we are substituting. So you can see that here this x, in place of this x we are substituting the 1 by 1 minus x. So after substituting this value we can see that what we are getting as this x we are getting finally f of x, f of x. So slightly bigger thing. So it seems to be again continuous because x seems to be continuous, but we know already it is already discontinuous at x is equal to 1. So basically at x is equal to 1 it is discontinuous. So it means we can say that my f of x and my f of x are also discontinuous respectively at x is equal to 1. So please be careful about that. Means my composite function will always be discontinuous at all the values of g of x and x, basically where basically you can say that where my g of x is discontinuous, okay. Let's see the question based on this concept, guys. So we have here f of x, we have here g of x, and they said discuss the continuities of f of x, g of x and fog. F of x, g of x directly you can say that, but the problem is composite function fog. F of x is x plus 1 divided by x minus 1. So you can directly say that the point of discontinuity will be nothing but 1. When we are keeping the denominator equal to 0, so we are getting as 1. So f of x is discontinuous at x is equal to 1. Now when we talk about the g of x, so this is discontinuous at x is equal to 2, because we can keep directly this as 0, the denominator as 0, we can get the answer as discontinuity problem. Now first we'll find the f of g of x, which is basically fog. Fog of x. Now how to find it? So in f of x you just substitute the in place of x, replace x with the g of x. It means one by x minus 2 plus 1 by x minus 2 minus 1. This is my fog. Now as I said, my f of x is discontinuous at x is 1 and g of x is discontinuous as x is equal to 2. So my fog of x, so it will be discontinuous discontinue at first point is at x is equal to 1, we know that, and second point is, no, one more thing, it is discontinuous x is equal to 1, f of x is discontinuous x is equal to 1, but this is discontinuous x is equal to 2. Why I'm telling about x is equal to 2? Because we know from the composite function my fog will be discontinuous wherever my g of x will be discontinuous. So my g of x is discontinuous x is equal to 2, so my fog will be discontinuous x is equal to 2. Now second point is my fog will be discontinuous at g of x is equal to 1. Why g of x is equal to 1? Because g of x is equal to 1, this is a 1 is the discontinuity point of f of x. So that if my g of x is equal to the discontinuity point of f of x, there also my fog will be discontinuous. So how? So what will happen by keeping this is equal to 1? So let's see. G of x, we know that this is nothing but 1 by x minus 2. So where we are putting 1, so x minus 2. So x minus 2 is equal to 1, so x is equal to 3. So basically we can say that at x is equal to 3, my fog is discontinuous. So my fog is discontinuous basically at 2 points, at 2 and 3. Okay, we can stop here also, but the problem is they said discuss the discontinuity. You can see the question clearly said that discuss the continuity. So we got discontinuity point, but still we know discontinuity also had two types, removal and non-removal. So we'll check this thing. So we know that fog is, we already got as 1 by x minus 2 plus 1 and 1 by x minus 2 minus 1. Now if I'll substitute 2 here directly, then this will be not defined. So how we are saying that this is discontinuous at 2 basically? So yes, it is not defined, this is discontinuous, but if I'll use limit x tends to 2 for my fog function, so limit x tends to 2, 1 by x minus 2 plus 1 divided by 1 by x minus 2 minus 1, this gives a value, finite value. It means what finite value we are going to get? We are going to get as 1 by 1, which is nothing but 1. It means 2 is my removable discontinuity, means we can remove the discontinuity. That is a type of discontinuity, we have already learned about it. So 2 is my removable discontinuity. Like this we can check about the 3 also. So if I'm going to check for the 3, so limit x tends to 3, my 3 positive first I will check, the right hand limit I will checking for the fog. So limit 3 x tends to 3 positive, 1 by x minus 2 plus 1 divided by 1 by x minus 2 minus 1. So by this clearly this if you are going to substitute as 3 minus 3 plus h in place of x, so you are going to, after solving this, we are going to get this as a negative infinity. So we are going to get this as a negative infinity, and limit x tends to 3 negative fog of x when we are solving this. So 1 by again limit x tends to 3 negative, so what we are going to get as here infinity only. It means yes, my function fog is discontinuous at 3, but it is a non-removable discontinuity. We cannot remove this, we cannot do anything. So it is a non-removable discontinuity. That is the only part we missed here. So that's why 2 and 3 we can say directly answer is that, but what is finally actually correct answer is 2 is non-removable discontinuity and 3 is 2 is removable discontinuity and 3 is non-removable discontinuity. Okay guys.